All right, ladies and gentlemen, we're going to be talking about some shortcuts on how to prove triangles congruent. Keep in mind, this is stuff you learned before, so this is a lot of review. So let's just throw out the definition of what makes two triangles congruent. So how can I know that this triangle and this triangle are congruent? And when I say congruent, I want you to think of them as twins. How are these triangles twins? They are exactly the same. In order to show that they are congruent, you actually, by definition, know 6 different things that are actually congruent to each other. When I say things, I mean parts. So we have to know 3 sides are congruent, and we also have to know 3 angles are congruent. So let's get started. So we have to know that AB is congruent to DE. And we know that because of the marks. We also know that EF is congruent to BC. It's pretty simple here. The drawing here does a great job of just marking everything for us. And then the last side we have to know is we're going to know that AC is congruent to DF because they have matching marks, AC to DF. So all the sides are congruent. Now we're going to look at the angles. So angle A is congruent to angle D because they have a matching arc. Angle E is congruent to angle B because they have 3 arcs. And last but not least, angle C will be congruent to angle F because of 2 marks. So angle C, angle F. Okay? Because all 3 things, all 3 sides are congruent and all angles are congruent, we can then say these 2 triangles are congruent, and we would write our congruent statement. So hopefully this is ringing a bell as we go through this. Remember, when we write our congruent statement, we also have to write it as A, who does it match with in the other triangle? In that case, it would be D. B matches with who in the other triangle? And that would be E. And C matches with who? That would be F. So that's our congruent statement. And if we want to compare this to a rigid transformation, what a rigid transformation, if you forgot, is like translation, rotation, reflection, all that stuff. Congruence is very much like what we call a translation, where we move one triangle to the other. So if you think about it, doesn't it just look like these 2 triangles have just moved? They're exactly the same triangle, same size, same shape, everything. They just moved over. Okay? So this is the definition of triangle congruence. If 2 triangles are congruent, then you can say all these things about it. All the angles are equal and all the sides are equal. Or in geometry, they are congruent. Okay, guys, what I put here is very, very helpful. All right? These are basically the steps to show that triangles are congruent. It's pretty much straightforward. The hardest steps you're going to encounter is step 2. Because this is where you have to know basically your vocabulary here and know what they mean. So I've given you some examples. This is the part where you look at the drawing. In this case, we have this example, and try to figure out, can I say something about the drawing? So if you look at this in step 2, if I was doing this problem, step 2, what I would notice is that this is actually vertical angles. So this is an example of how step 2 would be done. Okay? And you always want to draw whatever you know about step 2 into your drawing, just like I did here. I now know this angle is congruent to this angle, and my reasoning is vertical angles. So this is very helpful on your steps. Step 1, you want to label the information given to you. Step 2 is the hardest part. You have to come up with information based on what your drawing looks like. Okay? And then step 3, as we're going to talk about later in the slide, you're going to try to decide what shortcut do I have. Do I have side, 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 angle, angle, side, all that good stuff we talked about. And what's really cool on how to figure that out, when you're trying to figure out your shortcut, keep in mind this idea. You can only skip one part. What I mean by that, when you find things congruent, you can only skip a side. Let's say, for example, right here I have an angle congruent. I skipped the side, so I'm skipping the side part because I don't know anything about the side. But then I have another angle, and then I have a side congruent. So if you look, I've only skipped part 6. I have 1, 5, and 4. So I have an angle, side. So this guy, as we're going to talk about in a little bit, this would be angle, side shortcut. Okay, because I only skipped, going in order, I only skipped a side. I have angle, skipping a side, another angle, and then I got the other side. All right. So again, if you have to do triangle proofs, this is what you want to use in order to get the steps for triangle proofs. Step 2 is always going to be the most difficult. Okay. And last but not least, you cannot say things are congruent or things equal 180 just because they look a certain way, just because you feel that they look congruent or they look like they add up to 180 or it looks like it's 90 degrees. You must provide a reason, okay? So that's the huge warning. Okay, before we get into our first shortcut of side, 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 I want to do a little bit of review and make sure we understand the difference between congruence and equal, okay? Congruence means we're talking about the actual object, the picture. For example, angle A is congruent to angle P. That means the angles are congruent. It has nothing to do with the measurement, not the number. The actual angle is congruent, okay? Because these angles are congruent, by definition, congruence means that their measures are equal. So that means their numbers of these angles are equal. So now we can say measure of angle A is equal to 60. Okay? It's not equal to measure to angle P. It's equal to 60. Same thing here. I can say BC in the picture, so we're looking at side BC. Okay? I can say it's congruent to QR. But BC can never be equal to QR. What BC can be equal to is a number. Okay, so BC is equal to 5. So again, just a real quick review. Congruence means that they are equal to different parts. Congruent, you can never say angle A is congruent to 5 or a number. You can never say the measure of an angle is equal to a part. Okay, equals only comes with numbers. And hopefully that helps you understand that a little more. All right, let's go to side, side, side. So what side, side, side means, and again, this is review, is if you have 3 sides here that match and are congruent to 3 sides over here. So if we do this real quick, we can say BC has 1 arc or 1 dash, and its matching is QR. Okay, so that's 1 side down, and then we go to the next arc. We have CA. So CA has 2 dashes. We can now say that RP is congruent. Okay, and then last, AB has 3 dashes. That means QP has 3 dashes, and therefore AB and PQ are congruent. Okay, because of that, we can now say triangle ABC is congruent to triangle, and make sure, again, we match. Who does A match with? So if we look, A matches with P. Who does B match with? If we look, B matches with Q. And last but not least, who does C match with? C matches with R. Okay? And the reason we can say these guys are congruent is because we're using side, 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 which says we only need 3 sides to be congruent. It's a shortcut. We don't even need to talk about the angles. So now we can say it's by side, side, side. Okay? So real quick, an example A over here, if we were doing a proof, the dashes are given, and remember I talked about step 2 where you have to come up with something from the drawing. If you notice, one of the common things that we can say is that AC, this line here that I'm going to highlight, AC, we can then say is congruent to AC. So when something is congruent to itself, that means it's the same line. That is called reflexive property. Okay? What you'll notice on reflexive property is we actually have 2 triangles here. We have triangle on top, triangle on the bottom, but they share a side. So this side actually belongs to the top triangle, and it also belongs to the bottom. So even though it's 2 triangles, this side is congruent to both of them. This is called reflexive property. Reflexive property happens when triangles share a side or they can share an angle. So anytime you see a part being shared, a side or an angle, think reflexive property. Okay, guys, on your Google Classroom, I want you to go ahead and answer this in the comments. So what additional 3 corresponding parts do you know are congruent? Remember, CPCTC stands for corresponding parts and congruent triangles are congruent. So corresponding parts and congruent triangles are congruent. So now that these 2 triangles are congruent, what other 3 parts can you tell me are congruent besides the sides? Okay, so our next shortcut is side, angle, side, SAS, congruence. And this is how it works. So if you look, I have AC, a side, and it's going to be congruent to RQ. Okay, so I'm going to put that there, and this is given to us basically because of the marks. So I know those are congruent. And then I also have an arc for angle A, which matches with angle R. I know they are congruent because of the arcs, so this is angle R. All right, and last but not least, I have AB congruent to RS. So RS. Okay, so now I can use side angle side to say that these 2 triangles are congruent. If you notice, I'm going to start with this triangle. Remember, I only can skip one part. So if I go side, angle, so I have the side, not skipping anything, I'm going to the angle, still not skipping, and I go to the side. So I have side, angle, side. Therefore, I have SAS, and now I can go ahead and write my triangle congruence. So angle A is congruent to angle A, so remember we're matching. A matches with who? R. C matches with Q, and B matches with S, and we know this by side, angle, side. Okay, so I want to jump down to here and really answer this question. Why would side, side, angle be incorrect? So if you look, if we try to go this way and go side, side, angle, so I'm going side, side, angle, so we have a side, I'm skipping an angle, so I'm skipping one thing, And then I'm skipping another part. I'm skipping the side. So I'm actually skipping an angle and a side. So I'm skipping two parts. Remember, the rule is you're only allowed to skip one part. So right there, I cannot say side. So side, skip, skip, side, angle. I skip two parts. Therefore, side, side, angle would be incorrect. Okay? That's why we have to go this way. Side, angle, side. And I'm not skipping any parts. All right? So moving on to the example. Again, if I'm trying to use step 2 in triangle proofs, what thing can I get from this example? Okay, so what congruence statement can I get from this? The first thing you should notice, at least I do, is again, we are sharing a side. So I can say MT is congruent to MT, and this would be by reflexive. Remember, when they share a side, when two triangles share a side, that's reflexive property. You just got to tell me what side they share. The other thing you should notice is a big hint is parallel lines. So if this is parallel to this, you should also be able to say this angle and this angle are congruent. So angle M is congruent to angle T, and because it's parallel, this is alternate interior angles. So again, this example, we're just practicing some step 2 in triangle proofs. Again, if you look here, we now have, if you look at this triangle, I'm not going to do a full proof, but we have side, angle, side. If you look at the top triangle, we have side, angle, side. So this is an example of SAS. Okay, next shortcut is angle, side, angle. So let's see how this one works. So if you recall, I'm going to have angle X. So angle X has two arcs, and we know it's congruent to angle A with two arcs. So let's write that in, angle A. And now we have side XY. XY has one dash, and AB has one dash, so XY and AB are congruent. And last but not least, Y and B are congruent because they have one arc. So again, let's look at one of these triangles and try to figure out if I have the angle, side, angle shortcut. So we start at one of these parts. I'm going to start at angle. And remember, I cannot go this way because I would skip. If I go here, I would skip a side. I would skip an angle. We're skipping two parts. So we're going to go this way. So we have angle, then we have a side congruent, and we have another angle congruent. So I'll say that again. We have an angle congruent, side congruent, angle congruent. Angle, side, angle. So these two guys are congruent by angle, side, angle. So I would write that down. So triangle ZYX is congruent to triangle C. Remember, we got to make sure these letters match. C, and then Y matches with B, and X matches with A. And this is by angle, side, angle. So briefly, let's do this example, a real quick proof. I'm not going to do a full-on proof. So if we look here, we have angle, side, and to use this, I would notice in the drawing that I do have vertical angles, so I'm going to write that in. I know that angle C and angle C here are congruent, and this is by vertical angles. Okay, again, I'm not doing a full proof. We're just kind of looking at it. Now, because of those angles, if you look at this triangle here, it's angle, side, angle is congruent to this guy, angle, side, angle. So we would be able to use angle, side, angle there. All right. So I waited a little bit to talk about this, but what additional 3 corresponding parts do you know are congruent? So we know these are congruent. Okay, we know X is congruent to A for angles, Y is congruent to angle B. So if you look here, what angle are we missing? We already know they're congruent, so since they're congruent, we can then put their parts congruent. So I can now say angle Z is congruent to angle C. So angle Z is congruent to angle C. That's an additional part we can talk about now because the triangles are congruent. The other thing I can say is side AC is congruent to who over here? Remember, these are congruent, so I can start putting sides congruent. So AC can be congruent to XZ. All right, and then what's the other part I can say that's congruent that's not listed yet? We can say CB is congruent to, so CB is congruent to ZY. And now if you notice, we have all three angles and all three sides congruent. And we only can say this once we know the two triangles are congruent. All right, the next shortcut is called angle, angle, side. So let's get started. We're going to start with angle B. We know it's congruent to angle Z because of the marks. So we'll put that in, angle Z. All right, and then angle A is congruent to angle Y. That's a nasty angle mark. And then we have AC is congruent to YX. Okay, and now how does angle, angle, side work? Remember, you cannot skip more than one part. So let's look at this triangle here. So we're going to start, we could start at side and go this way. So side, we skipped an angle, we skipped a side. So we can't go that way. So we can go side, angle, skip a part, angle. So side, angle, angle. All right? So side, angle, angle, if you think about it, it's just this in reverse, which is okay. You can have side, angle, angle, but the proper way of talking about it is starting with an angle like this guy and finding the next angle. So angle, skip, angle, side. And this would work because we're allowed to skip one part. So we have a congruent angle, we're skipping a side, we have a congruent angle, and we have the other side. So this would be angle, angle, side. So let's write that down. CBA is going to be congruent to matching the parts X, Z, Y. And this is by angle, angle, side. Okay? So looking at our example here, if you notice, we have in the left triangle, we have angle, angle, and we would need a side. Or we could start at this angle, angle, and get this side. So looking at the drawing right off the bat, again, we have two triangles that share a side. So we should be able to look at that and say, oh, that's reflexive property. So I would then say BD is congruent to BD. So there it is. There's a side congruent to both triangles. So now I can use angle, 90-degree angles are congruent. So angle, angle, side. Okay? Again, I didn't do a formal proof, but you get the idea. All right? Go ahead and see if you could write the three additional parts that are congruent using CPC-TC. Corresponding parts in congruent triangles are congruent. We did in the last example. And then last but not least, why would ASA be incorrect? So to answer that, ASA would assume that we're going angle, side, angle. But if we go that direction, angle, skip a side, skip an angle, we're skipping two things, and we get to our side. So we ended up skipping two parts, which is we can't do. Okay guys, our last shortcut is hypotenuse leg congruence theorem. The thing we have to understand is our hypotenuse is always the side across from the 90. So this would be our hypotenuse here, and this would be my hypotenuse here. So with hypotenuse leg congruence, you have to have a right triangle, and you have to have the certain parts. For example, you have to have, in this case, we know that angle B and angle P are right triangles, and they are congruent. Okay? And then we have to have their hypotenuse congruent. So, a leg congruent. Again, a leg is just another side that's not the hypotenuse. So if you look here, BC is congruent to PR. So that would be my leg. We already know these are right angles. These are 90 degrees. Okay, only works for 90 degrees. And then last is we have to get our hypotenuses equal, or congruent, sorry. So if you look, my hypotenuse is AC, and it's congruent to the other hypotenuse, which is going to be QR. Okay, so CA is congruent to RQ, okay? And that would be my hypotenuse. So we have 90 degrees, so it only works for right triangles. We got a leg congruent, we got the hypotenuse congruent. Once we have those two parts, we can then say these two right triangles are congruent. So angle, or triangle BAC is congruent to triangle P Q, R, and this is by hypotenuse leg. Okay, so go ahead and I want you to try this guy just to get some practice in and answer this question on your notes. All right, and that should do it. Let's go ahead and look at this example here. So again, we have 90 degrees here. Those are right triangles. Okay, so BD is actually the hypotenuse. All right, and we also know that BD is congruent because of reflexive. Remember, they share a side. This is reflexive, so they're congruent. So now we have a hypotenuse congruent, and we also have a leg congruent. Okay, so this would be congruent by hypotenuse leg.